Hi, my name is CallumWalters. This is my coursework 2. This section demonstrates saving and loading player score to local storage using JSON, base64 encoding, and AES encryption. Before playing for the first time, the no score text panel shows as no saved data exits. Let's quickly play so that it saves the best score. This is the player data class. It stores the information I want to save locally, including the player's username, best score, date, number of players in the match, and the room name. This object is converted to JSON when saving. This function saves the player data to local storage. First, I serialize the player data object into a JSON string. Then I encrypt the JSON using AES, which produces encrypted bytes. I base64 encode those bytes so the data can be stored as text. Finally, I write the encoded string to a local file. This is the saved file stored locally. It is not readable JSON. Instead, it contains base64 text because the JSON has been encrypted and encoded. Loading reverses the process. The file is read from local storage. The base64 text is decoded back into encrypted bytes. This data is decrypted to recover the original JSON string. Finally, the JSON is deserialized back into the player data object. For encryption, I use AES with random sort and internalization vector. A 256-bit key is derived using PDK DF2. The salt and IV are stored with the encrypted data so it can be decrypted later. During loading, the same key is regenerated and AES is used to decrypt the data back into the original JSON. Loading, the saved player data is displayed in the personal best panel. The script reads loaded player data from the game manager and updates the UI fields with the saved values. A small quality of life feature I implemented that allows the player to export their saved personal best data to a readable text file. This does not replace the save system, it simply reads existing saved data. When the button is clicked, the game reads the already loaded player data and writes it to a text file in the Safe Unity folder. The script first checks that data saved exists. It then formats the player data into a readable text. Finally, it saves the text file using application persistent data path, which is a Safe Unity managed folder. On the Windows, this file is saved to. Demo of this part. This is the rating room chat implemented using font on chat. Only players in the same room can see each other's messages because I used the current room name as the chat channel. In multiplayer lobby CS, when a player joins a room, I always connect them to the photon chat using their nickname for authentication. Then the chat script subscribes to their channel using the room name. In chat.cs, when chat connects, it subscribes to the channel named after the photon room, so it becomes a private room-based chat. Incoming messages are handled on get messages, where I read the channel's message history and display it in the UI text. In multiplayer lobby.cs, when leaving the room, I disconnect from chat so it cleans up properly and doesn't keep the old channel. This completes lobby chat using font on chat with room-based channels and messages displayed in the UI. This is the in-game chat. It runs only in the multiplayer scene. The chat panel can be toggled during gameplay with a hotkey, but it stays connected in the background. In in-game chat.cs, the key part is that the chat channel name is font on room name, so only players in the same match can communicate. Pressing the toggle key enter shows or hides the UI panel without disconnecting chat. When the chat is open, enter sends a message, so this shows my implementation for in-game chat plus a hotkey to show and hide the chat panel during gameplay. As a quality of life feature, I added simple profanity filter to both the lobby chat and the in-game chat to improve player experience and demonstrate responsible multiplayer design. InChat.cs and in GameChat.cs, a small list of mild coursework appropriate words is sorted in an array. These are checked before any messages is sent. Before sending, each message is passed through a filter. The filter replaces any banned word with asterisks and check in case insensitive, so variations like uppercase or lowercase are also filtered. When a player sends a message, it is filtered first and only then cleared message is sent through the font on chat. This ensures inappropriate language is blocked in both lobby and in-game chat without affecting gameplay or networking. I've added a quick little demo for you guys. Now showing implementation for this part. This is my global leaderboard powered by PlayFab API. It records player performance globally, so scores persist between sessions and across different players. In GameManager.cs, when the game starts, the game manager logs into PlayFab using a custom ID stored in player data. This ensures the player is authenticated before submitting or requesting leaderboard data. In Multiplayer Level Manager, when a match ends and a player achieves a new best score, I submit that value to the global leaderboard. This prevents spamming PlayFab every round and only updates when the player improves. In GlobalLeaderboard.cs, submitting a score uses update player statistics request with a statistic name. In my case, the leaderboard is stored under the statistic called most kills. To display the leaderboard, I request the top entities using getLeaderboard request. In leaderboard popup.cs and leaderboard item.cs, when the leaderboard pop-up opens, it automatically requests the leaderboard from PlayFab. The results are then converted into UI rows using leaderboard tem, showing rank, username, and score. Alongside the most kills leaderboard, I added a second global leaderboard based on custom metric quickest win. The global leaderboard quickest win.cs script works the same way as the kills leaderboard, but it tracks how fast a player wins a match instead. When a player wins, their win time in seconds is sent to PlayFab. PlayFab leaderboards rank scores from highest to lowest by default, but the quickest win, we want lower times to rank higher. To solve this, I store the time as a negative number. For example, 30 seconds becomes minus 30, which makes higher than minus 60. To display the leaderboard, I request the top results from PlayFab using the same statistic name. The retrieved leaderboard data is passed to the UI script, which displays the ranked. This creates a second global leaderboard using a custom metric fully integrated with PlayFab results. And thanks, guys. That's the end of my coursework demonstration. Thanks for watching. I've been CallumWalters. Thank you very much. Make sure to like and subscribe and leave a comment down below.